Hello, 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 and welcome to my first ever tutoring live stream. I thought this would be a fun project for you guys to give an opportunity to not just tell you what to do, but to show you what to do. So all the techniques I'm telling you to use, I'm not going to be a raging hypocrite. I'm going to show you how it works in practice, how you can use them to the best of your ability. This is still very much in my head like a beta test, still in development phase. So I'm going to be working out exactly how I want this to go. So today, nothing too fancy. I'm just going to dive in and do the 2022 papers to show all of you all the stuff I've already been describing. Now, on the off chance this makes it to anyone who isn't a current student, I'm going to do a little bit of explaining about what I'm going to be doing. So let me get my screen shared. Window, entire screen, second screen, let's go. So the first thing you need to know about my approach to the ESAT is how I analyze any errors I make. So in my book, there are three types of error. First of all, there's a conceptual error, which is just, do you know the math? Do you know the physics? Really simple. You either get the question or you don't. And there's nothing, I find that when I meet a conceptual error, I'm like, oh, cool, I just didn't know the question. Fair enough. You got me. The second type is an execution error, which is where you know exactly what you're doing, but you just make a small issue. So that's something like a sign error, which is my classic. So writing a plus instead of a minus or the other way around. And another weird thing, so every brain is kind of unique in what types of execution error you make. So I find with my brain, for some reason, I'm really bad at adding and subtracting 9. No, don't know why, it just happens. So ideally, I'll be trying to minimize those by being very careful with my work. And the third type of error is exam technique. So this is one where you just don't read the question, or you get the right answer and you just choose the wrong one out of the multiple choice anyway. So in my tech run that I did the other day, that is exactly what I did. I totally got the right answer and then circled the wrong answer. Just wanted to throw myself out a window because that's how it feels to be so close to it and just not get over the line. So what I'm going to do is I'm going to go through the paper and I'm going to mark it. Any mistakes I make, I'm going to be describing in those terms. The second thing you need to know is my strategy for how to move through an ESAT paper. So I advocate for what's called a multiple pass system. And the reason why you want to do that is because it is so fast. 90 seconds a question goes by so quickly, and it's very high pressured. So the worst case scenario is you see the first question in the paper, you decide you absolutely hate it, but you can't move off it. And so you spend 5 minutes working through it all, not even getting it right, burning through all of your time, you know you are behind, and then you rush all the rest of them, and you make mistakes you wouldn't make otherwise, and your entire paper falls apart. So using a multiple pass system, what you do is you skip all the questions, but you look at them and do not immediately see exactly how to solve them and know you can do them quickly. I also find this is really good psychologically to make sure that the first question you do is really solid and it grounds you in the paper and builds this narrative of how the paper is going. So the analogy I make is it's kind of like getting the first laugh at a comedy routine. It kind of eases the nerves, settles you in and goes, all right, this is going to be fine. And you're going to see that a lot. I'm going to look at a question and go, no, not now, not now, not now. But once I find the one I like, that eases me into the paper. And more often than not, then I answer every question after that, just sort of getting into the groove, getting into the rhythm. Then in the second pass, so after the first pass, you've gone through, you've answered all the questions, you've got them right, you've done them quickly, you've built up a time bank. And so you can relax and do those more difficult questions that take a longer time with the allotted time you've built up for yourself. And I find as well that if you do not get to the end, it means you've been very tactical about which questions you leave behind. Instead of going through from front to back, leaving 5 doable questions at the end that you could have got, it means if you are leaving anything blank, it's the ones where you would have been guessing anyway. So it maximizes your marks per minute and gets the absolute best out of you. Now, in the NSAA and ENGAA papers that we have online, they are, roughly speaking, grouped in order of difficulty. So they start off easy and they get harder. So to incentivize me to really think about multiple passes, I do them back to front. I start with the really difficult questions, and that means that I know that the good questions are at the end waiting for me. So I'm more likely to let myself skip those early difficult questions to get through to the shiny, easy questions at the end. Rather than going, if I go like in the regular order, then chances are I'm going to just want to do all the early questions, and I'm not practicing that new technique of letting myself skip tactically. So I'm going to go back to front. I'm also going to be doing, for Math 1 and for Physics, I'm going to be doing the NSAA. It's all the same content as the ENGAA, but the ENGAA has them all mixed together, which is unlike what you'll see in the ESAT. The NSAA has them separate, and the NSAA has slightly more questions, which means there's just, more to get into, makes it more worthwhile. And for the Math 2, I'm going to be doing the ENGAA because the NSAA gets rid of Math 2 from 2020. Also, I think this should be implicit by now. I'm going to be doing just the Math 1, the Math 2, and the Physics. So I do a lot of work with people who are going for physics, natural sciences, Cambridge, or they're going for engineering, which requires Math 1, Math 2, Physics. But the techniques I use can still be applied to the other experimental sciences. It's just not going to be the focus of today. Okay, all my regular students, you already know all of this. I say let's just sort of get in. Oh, one last thing. I'm going to be taking split times. So I'll know exactly how long I've spent on each question. And then we can kind of analyze that at the end, see where my technique was used well, see where my technique could have been refined, and kind of put myself in the trenches in the same position that you're in, rather than just be one of those teachers who calmly and quietly explains it after the fact. This should be a demonstration of psychologically how to move through the motions, as well as just academically how to move through. You guys aren't going to have the option to draw on the actual paper, so I'm not going to either. I've set up this Miro whiteboard that will allow me to do that. So I'm going to be working on here on the right in the Miro whiteboard, going through the questions on the left here. And I say, without further ado, let's get going. So I have to remind myself, because in the tech run, I was forgetting to write down the questions and I was forgetting to take some split time. So just going to hold myself accountable and hope I don't mess that up. All right. Oh, one last thing. Let's check the questions so I know how much time I have budgeted. So each of these has 20 multiple choice. So at 90 seconds a question, that means I should have half an hour budgeted. So that's good to know. Right, we're going to start on Math 1. I'm going to skip to the back, and we're going to go forward. So ready, and go. Right, graphs of that form, complete range, minimum point lies above the x-axis. Well, actually, I can do that straight away. So on 20, I'm going to complete the square on that. So y is equal to x plus a squared minus a squared plus a. And where that lies above the x-axis. So it means that this, a minus a squared, must be bigger than 0. So I can take an a out, and I'm going to get 1 minus a bigger than 0. So the y-intercept has to be bigger than 0. Cool. So I'm going to sketch that. So that goes through 0 and 1, bigger than 0. So a has to be less than 0 or bigger than 1, which is f. I'm going to lock that in. Split time. Let's go. Uh, 19 looks like it's going to take too long. Skip. This looks doable, but many steps. So I'm just going to come back to that. This again, I'm just not feeling that one. I'll come back to that. That's not very confidence building. Let me zoom out of this one. It's parallel to QR. Okay, this is similar triangles. This shouldn't be too bad. Let me have a go. So PST for question. Which question is this? This is 16. So PST, that's 3. That's X. And then I'm going to draw the big one. So that's going to be PQR, where this whole length here is going to be x plus 5. That's going to be 2x plus 1. So the length of QR, so let's look at the scale factor. So going from here to here, we're multiplying by x plus 5 and dividing by 3. So I'm going to do the same thing to x, and I'm going to get 2x plus 1. So I'm going to multiply both sides by 3 and multiply the x through to get x squared plus 5x is equal to 6x plus 3. Form a quadratic, minus x minus 3 is 0. Okay, then x is going to be minus b plus or minus the square root of b squared minus 4ac all over 2. And x is going to be bigger than 0, which means I want the positive case. So it's a half plus a half root 13. And this QR is 2x plus 1. So multiplying by 2, you're going to get, let me scroll down. So multiplying by 2, you're going to get 1 plus root 13. And then adding 1 to that makes 2 plus root 13, which is b. Okay. And I felt like it took too long, but we'll analyze that afterwards. Okay, so this, oh, brilliant. Okay, this is where I should probably have started because this is like, I got this. So 15. So x is 5 minus 2y cubed plus 1 over 1 minus 2y cubed. First thing I'm going to do is move this over. 2y cubed plus 1 minus 2y cubed is going to be equal to 5 minus x, not making a sign error. Multiply everything on one line. So 5 minus x into 1 minus 2y cubed, make by the subject. So 5 minus 10y cubed minus x plus 2xy cubed. We're going to get all the y's on one side. So that's going to be 12y cubed minus 2xy cubed. And I'm going to bring that over to make it 4, not forgetting my minus x. Take a y cubed out. 12 minus 2x, 4 minus x. Y cubed is 4 minus x all over 12 minus 2x. And I cube root that. Is that an option? Let's multiply. No, but I'll multiply top and bottom by minus 1 to get to minus 12. And I'm going to cube root that, and that is option E, so I'll go for that. Split time. Okay. Positive difference between the roots. Okay, I know how to do this one. So the positive difference between the roots comes from doing the quadratic equation. So you're going to get x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So the difference between the roots is due to that. So it's going to be twice, and I'll explain this more later. So that's the difference in the roots, which is 10. Cancels 2. Root of 16 minus 8c is going to be root 40. I'll explain. So 16 minus 8c equals 40. So subtract that across. No sign errors now. That's minus 24 is equal to 8c. So c is equal to minus 3, which is c. Split time. Okay. 13. Solid cylinder has radius r and height h. Cube. So the surface area of the cylinder, the total surface area of the cylinder, which is 2 pi r squared plus 2 pi r h, is equal to 4 times the surface area of the cube, which is 4 pi times the radius of cube, not sphere. Focus, read the question. 4 times the surface area of the cube. So it's 4 times the surface area of the cube, which is 3r cubed. Nope, again, that's the volume. Patrick, read the goddamn question. Right, so surface area of the cube, that's 3rd time's the charm. So that's 6 times 3r squared. Okay, there we go. So that's 24 into 9r squared. I'm going to divide both sides by 2 to give pi r squared, and pi r h is 12 times 9r squared, which is 108r squared. So we want h in terms of r, so pi rh is 108 r squared minus pi r squared. Take an r squared out, 108 minus pi. Divide by pi r, so that's r over pi into 108 minus pi, which is none of the options. Let's multiply the pi over pi n, so r into 108 over pi minus pi squared. What have I done wrong? So what's in this? It's 2 pi r squared and 2 pi r. No, okay, time. I'll come back to that. Not going great on that front, but all right, this happens. Don't let it disturb the flow. I can come back to it. I'll have time after the first pass. So a cyclist rides along a track, immediately turns around and descends along the same track to her start point. Takes 40 minutes at an average speed. Her average speed for the whole journey. Okay, so distance equals speed times time. She takes 40 minutes at an average speed. So the distance, that's 2/3 of an hour times 12 kilometers. So that's going to be 8 kilometers traveled in that first 40 minutes. Her average speed for the whole journey, which is total distance over total time. So plus the second distance over and then that time taken is going to be 2/3 of an hour plus how long it takes her to come down. And the average speed of her descent is going to be d2 over t2, which is 15. No. And then descends along the same track to her start point. So it's the same. So the total distance is 16. And she travels 8 kilometers back down in time t2. So this will allow us to work out t2. Okay. So 2/3 plus t2 is 16 over 15. Come on, right. T2, let's multiply this by 5. So it's going to be 16 over 15 minus 10 over 15 is equal to 6 over 15, which is equal to 2/5. And so the average speed of her descent is the 8 kilometers over the 2/5 of an hour it takes. So that's 40 over 2 is 20 kilometers per hour. So that's C for 12, split. Okay, 11. I got to speed up. So tan R S Q. Okay, I'm going to have to draw this out because you would have to as well. Tan of RSQ. So tan theta is 5/8. And that's 40. So tan theta would, so opposite over adjacent, but the adjacent is 40. So let's multiply this by 5. So that makes that 25. What is the length of PS? That's 25. Length of PS in meters. So that's 25 and that's 40. There we go. Okay, so, and then we have here tan 30 is 40 over, let's call this x. So x is 40 over tan 30. Now I'll use my special triangle. 1, 2, root 3. So tan 30 is 1 over root 3. So that becomes 40 root 3 plus the 25 is g. Split time. T is inversely proportional to the square of w. So t equals k over w squared, tw squared equals k. T equals 36 when w, so that becomes 4 times 10 to the minus 4. Actually, I'm going to do, so T1 W1 squared equals T2 W2 squared. So 36 times 4 times 10 to the minus 4 is 100 W2 squared. Divide by 100. We'll make this, so let's divide by 100. Well, let's just make that, so 36 times 4 carry 244 times 10 to the minus 6 is W2 squared. So 12 times 10 to the minus 3 is W, which is 1.2 times 10 to the minus 2. Yes, which is B. Okay. So 9. Come on, keep up. So rectangle, PQRS is length 2x, width 1x. Larger rectangle is made by adding 3 and 3. Larger rectangle has an area of that. Okay. So what does that mean? That means that x plus 4 times 2x plus 2 is 360. We can work out x. Ratio of PQ to PS. Okay, so we got to find x. Let's divide both sides by 2. X squared plus 5x plus 4 minus 180 is 0. So that's, oh, this is not going to be fun. Minus 176. Well, that's 16 times 11, so that works. So x plus 16, x minus 11. So x is either equal to minus 16, which it can't be, or so x is equal to 11. And so that becomes ratio of 12 to 21, which becomes 4 to 7, which is B. Okay. See, okay. Yeah, the easier ones were at the back. So I'm glad I'm getting to them. Okay, so 8, list of 6 numbers. The mean of S is 1 more than the median of S. So the median is going to be the average. So it's going to be x plus a half. That's the median. So the mean of S, so if I add 1 to the median, I'm going to get the mean. And the mean is 3x plus 1, 2, 3, 4, 5, 20. All over 1, 2, 3, 4, 5, 6. So x plus 3 over 2 is going to be equal to x over 2 plus 10 over 3. Let's multiply everything by 6. Okay. Then 3x equals 11. X is 11 over 3, which is 3 2/3, which is B. Okay, split time. Okay, there we go. This is going to be fun. Now we're into the fun part. Okay, that was so. First thing I'm going to do is actually factorize the bottom because I have a feeling something's going to cancel. So 5x plus 3, 5x minus 3. So times, I'm going to factorize the bottom one here into x minus 3x plus 2. This becomes x plus 4x minus 3, which will immediately cancel down. Nothing cancels there, so I expect there to be a 5x situation here and an x. I expect it either to be plus 3 or minus 3. So, so I'm targeting minus 60, and that would be minus 20 plus 3. So plus 3, and the minus 20 is going to come from that. So those cancel. And it's going to be x minus 4, x plus 2. X minus 4, x plus 2 all over 5, x minus 3, x plus 4. Right, so I see C. I'm going to go for that. Next. Okay, so 6. Nth term sequence is that. Nth term of another sequence is that. The 10th term in t, so I'm just slowing down for this is the important bit. So the 10th term in t, which is 49, is equal to twice the 5th term in v, which is 15 plus p. Is that right? So the 10th term in t, is, yeah, it's definitely 7 squared is 49. Okay. Okay. So that's 30 plus 2p. So 19 is 2p, so p is 19 over 2. So the 4th term in v is going to be 12 plus 19 over 2, 24 plus 19, 44, 43 over 2, which is 21.5, which is D. Might have been a faster way. But at least things are flowing a bit better now, so I'm feeling more confident. 5. What are your earns on each day? On Monday, you earned 50%. So if you earned, okay, so we earned X on Sunday. On Monday, here you earned X over 2. On Tuesday, here earned 20% more. So 1.2 is 6 over 5. So that, okay, so multiplying by 6 over 5 cancels 3 over 5. Cool. On Wednesday, here 30% as that. So he earned 70%. So that times 7 over 10 is 21 over 50x, which is equal to 84. Cancels 4, x equals 200. Right, which is D. Okay, split time. 4. 2 fair dice, x and y, each of which has 6 sides. That and that. Roll the dice together and calculate my score by adding that to that, probably being greater than 9. Okay, so that, I'm going to just two-way table it, but not fully do it in. So that's going to be 2, 3, 4, 5, 6, 6. There are 36 possibilities. And which are the ones that give me greater than 9? So that's 5 with 5, 6, and 6. That's 4 with 6 and 6, and 3 doesn't get you there. So that's 5 out of 36, which is E. Split time, not forgetting. 3. So find the complete set of values for which that's true. So let's multiply the whole thing by 4. So 15 minus 3x minus 12 plus 2x minus 4x less than 0. So that is going to be, so 15 minus 12, so 3 minus 7 minus 5x, bigger than 0, 3 less than 5x. X is bigger than 3/5, which is C. Split. Right angle at Q, point C lies on QR. I'll just draw my usual right angle triangle. Right angle at Q, PQR. T lies on QR such that QT is a quarter of the way. So T is a quarter of the way through from Q to R. So that's like there. So that's 1/4. So it splits it into 1:3 ratio. P to T is 6. P to R is 12. That's not necessarily 3 and 1. That's just the ratio. So if I call that x, that's 3x, for instance. What is the length of QT in centimeters? Well, I know that PQ is, so I know that if I call that y, I know that x squared plus y squared is 36. I know that 16x squared, which comes from squaring this whole thing, plus y squared is 144. What is the length of QT? That's x. So I'm looking for x. I can eliminate y. So subtract those. 15x squared cancels equals That minus that is 108, I want to say. Yep. X squared is 108 over 15. I know I can divide a 3 out of this to give me 5. Divided by 36. So x is equal to 6 over root 5, which is d. Okay, split. Final question of the first pass. Not a huge amount of time on the second pass. So which of the following is the implication of that? So y into 9x y squared over y 6, 9x z squared over y 5, which is e. Okay, done. Right, let's second pass this. Okay, so I've banked the good ones. Done it, 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 done it. That's not too bad, actually. Okay, I could redo 13, but I'll do one I haven't tried yet. I've done 14. I've done 15. Did I do 16? I think I did 16. Yep. Okay, let's go back to 17. Should really keep track. In the real thing, you have like something telling you what you have and haven't done, because you'd have flagged them on the way. I didn't flag them. Probably should have. Oops, whatever. So what is the probability that the three numbers form three sides of a right angle triangle? So the three sides, thingy squared plus thingy squared equals thingy squared. So when you square them up, the squares would be 1, 2, 3, 4, 5. So you can have 1, 2, 3, certainly. So 3 different numbers are chosen at random. How many different ways are there of doing that? So that's 5, choose 3. I'm going to use my A-level skills. Actually, 1, 5, 10, 10, 5, 1. So there's 10 different ways of doing that. Out of those, I could have 1, 2, 3 forms 1. 1, 3, 4. I could have 1, 4, 5. 3 different numbers. So you can't have 1, 1, 2. So I can have 2, 3, 5. So I'm going to say that's 4 out of 10, which is 2/5, which is E. Okay. And I'm more confident now. So I've got like 5 minutes. I've got time. So I can calm down, do things a bit slower, see if I can mop any extra points. So these are regular polygons. Q is 3 times as many sides as P. Okay. So an interior angle of Q. So an exterior angle of Q is 360 over NQ. An interior angle is 180 minus that. So if I just move across, so 180 minus that is the interior angle of Q is 10 degrees larger than the interior angle of P, which is 180 minus the interior angle of P, which is 360 over NP. And that interior angle plus 10 is the interior angle of Q. Okay, so let's replace that with 3NQ. Cancels for 120. Cancels that. So 120 over NQ minus 360 over NQ is equal to 10. And I'll swap that round. That makes sense. Hold on, I'm getting something wrong. And it's 3 times as many sides as P. Calm down, you've got time. So the interior angle, so the exterior is 360 over NQ. Interior is 180 minus that. That's the interior angle of P. That doesn't work. Doing something. Oh, let's just say, okay, fine. NQ is 24. I'll work out exactly what I did wrong later. which means that NP is equal to 8. I did it the wrong way around. NQ is 3 NP. Right, that should have been the 3 NP. So yeah. Cool. That's 120 NP minus 360. 120. So 36. Okay, 360 over NP minus 120 over NP is equal to 10. Cancels that down for 24 is equal to NP. Good. Which means that NQ is 3 times that, which is 72 is NQ. R is twice as many sides, so that is 144 is NR. How much larger is the interior angle of R than the interior of Q? So the interior of R is 180 minus 360 over 144. Divide by 12. Divide by 6. 180 minus 2.5. And that's compared with 180. What was Q? Q is minus 360 over 72. So again, let's divide 12. 5. So the difference between those is going to be 2.5 degrees, and that's A. Good second pass. Okay, I've got 2 minutes left. I didn't do 19. So let's have a go. So the point is translated to the point by 2 successive translations. The first translation is by that. Second translation is by that. So the total translation, you start off at -1.5, and then you're going 3p plus q and minus 4p minus 2q, and you're ending up at 3.2. What is the value of p plus q? Well, let's work this out. So 3p plus q is equal, well, minus 1 plus that equals 3. So 3p plus q is equal to 4. 5 minus 4p minus 2q is equal to 2. So adding that across, so 4p plus 2q is equal to 3. If I subtract these, then I get that p plus q is equal to -1, which is d. So not much time left. Is it worth checking anything? I think I got that. Got it. Which is the one I got wrong. I know I got wrong. It was this one. Oh, that's a shame. I normally love these questions. Come on now. Where's 13? No, I'm just going to have to redo it. No, I've got 42 seconds. I'm not going to get it done in time. So I can guess, though. It was 108, so I'm going to guess G. I'd bank that. Done. Stop. Just in time. That was not a good run. Uncharacteristic on my part. Right, so let me get into it. I'm going to go through the splits. I'm going to go through the analysis. Let's just first find out how bad that was. Okay, I'm going to zoom out. Let me get my answers. So let's see how many I got wrong. So 20. This is NSAA section 1. So 20. Oh, damn, right off the bat. Not great. 20 at C. Did I get the sign wrong? The minimum point lies above the x-axis. Well, the minimum point here is going to be at minus a and a minus a squared. We need that to be above the... it's a negative a squared graph. God damn it. Execution error. It's a negative a squared graph. So I did everything right apart from that. It should have been in between. That I should have got. That's annoying. And that's the thing. So I think the fact that I'm on camera sort of presenting live does a very similar thing to what happens when you're in the real thing. It puts that pressure on you, gives you that tunnel vision, and stops your brain working at full capacity. So I'll have a think. So what I should have done is recognize that I had more time than I thought, and I should have given myself the grace. Like it's saying I got told, slow is smooth, smooth is fast, and I should have just calmly told myself that. Oh, that's annoying. Oh, that's annoying. Okay, 19 was down there. I got that as... I probably stopped writing down the question number. Which one was 19? The translation. So it said D minus 1, didn't I? Got it. Cool. This one I said 2.5, I think, which is A. Got it. I think I gave pretty good explanations as I'm going through, so I'm not going to re-explain these things. You guys can let me know afterwards whether I should go back through them slowly, but I don't think I have the time before my afternoon session starts, so I'm just going to go through. So 17E. Yep, got that. 16B. I think I actually had a go at this. We're just checking answers first. So 16B, yep. 15E, correct. 14C, correct. 13, I think I guessed G. I don't know what went wrong there. Let me have another go. Guessed it correctly because I got something of that form, and so I just went for it. So what did I do wrong? 108 R over pi, certainly. And I should have just got minus R. Oh my god, I'm a flaming moron. Oh my god! That is such a bad execution error. What am I doing? Since in what universe, in what conceivable universe is pi divided by pi equal to pi squared? All right. God damn it. This is what happens under pressure. Your brain makes mistakes under pressure at speed that it would not make slowly. But I knew I was there or thereabouts, and so it allowed me to guess something of the right form. So even though I made a mistake, I was able to get the right answer, which is something you can do in the real thing. God damn it. All right. 12 again. So 12 I got C. So 13, nope. We're going up. 11 I got G, but wasn't hugely confident. Yep, nailed it. 10 I got B. Yep. 9 I got B. Yep. 8 I got B. Yep. 7C. 6D. 5D. 4E. 3C. Oh, I got that wrong. How did I get that wrong? Was it just a sign? I bet it was a sign error with the inequality sign. Let me try this again. Okay, this time I'm going to do it like just annotating on the thing. So I'm going to multiply by 4. So 3 into 5 minus x, 2 into 6 minus x, minus 4x is less than 0. 15 minus 3x minus 12 plus 2x minus 4 less than 0. So 3 is less than... Oh, good God. I literally... I said I did this last time. I got the right answer and circled the wrong... Everything's fine. I'm fine. I'm a healthy, well-adjusted adult, and I can cope with this situation. So anyway, I got the right answer. I just circled the wrong one. Moving right on, you saw nothing. There is no evidence that this ever happened. Question 2. D, yeah, and 1 was E. So I got 2 of those wrong. One of which was a silly execution error of not getting the minus a squared graph. One of those was the mother of all technique issues, which was getting the right answer and circling the wrong answer because I had things... What I should actually know, that was an avoidable technique issue. That was a totally avoidable technique issue. What I should have done is, if I saw that the x was on the left, what I should have done is rewritten it that way explicitly So I couldn't have mistaken that. That's on me. That's how I can mitigate that technique issue in future. And how I can mitigate the minus a squared thing is honestly just look for it. And maybe I shouldn't have started on that question. Maybe it was too fresh for me to start doing that. Right, let me get some splits. So looking through, it's going right back to the top so we can see it in order. So this first one, I got that done in 41 seconds. Would have been perfect if I'd actually done it correctly. I skipped 19 in 10 seconds. I skipped 18 in 6 seconds. I skipped in 6 seconds. So you can see these skips are quite quick. I'm making good, quick snap judgments, so I'm not wasting too much time. I'm saving that time for when I do it in the second pass. Next one I did, this 16 was done in 147, a little bit over budget. And I think, as I said at the time, that means that I maybe should have saved that for the second pass as well. Then this one I did in 121, which was perfect. Then 57 seconds. Then 208 because I was messing it up and couldn't see why, but I came back and guessed it okay. This was, again, 2 minutes and 6. So I was over budget here, but just still powering through because I knew I could. And I knew I would make up the time. So this was in 145, again, still over budget. This is where I started getting back on track. So I did this one in 1 minute 20, then 1 minute 20, then 1 minute 10, 1 minute 11, 104, 57, 52, 56, 145, but in fairness, I was very close to the end of my first pass, so I didn't mind going over, and there was quite a few steps. And then that was done in 20 seconds. So coming through then for the second pass, this was done quite quickly. This was done in 147, quite good for a second pass. Then, excuse me, then this was done in 4 minutes because I just messed that all the way up, but I found my way to it in the end. Then 108 there, and then I guess the last one in sort of 38 seconds to finish off. So god damn it, that was a wobble, but I still managed to get 18 out of 20, which is a solid score, and it really could have been 20 out of 20 if I'd just been a little bit more diligent. So even though I was really wobbling on the path of that, I managed to find my way through, so that's good. Now I'm going to go over to the math 2 because that's the order I had a guy do it last year. He didn't have a choice over which order he did it in. He went math 1. They served him up math 2 right away. And then they served him up physics. So that's what I'm going to do now. So there's 20 questions in here, but they are a mixed math and physics. So only 10 of those are math. So that should leave me 15-minute budget for doing the math 2. So I'm going to see if I can rally myself. Now, in the real thing, obviously, you don't get that feedback. So I wouldn't have known how well I actually did. I would have just known that it felt bad. So it would have been important for me to just reset and just try and hit it fresh. And just pretend. But also, like, okay, knowing that now, look how bad it felt like that was going for me. I would have been like, oh, that was going terrible. I got 18 out of 20. So if you're feeling bad, it doesn't mean it actually went bad. And so you can kind of use that to rally yourself and go, okay, no, don't know what you're talking about. It's not about, it doesn't matter if you stumble the whole way. It only matters that you get over the line, right? So it's like, well, nope, don't know what you're talking about. Denial. I did completely fine. Ignore the situation. So we're going to math to it. It's going to be the odd numbers working back from 39. 10 questions. I'm going to still work that multiple pass technique. These questions are going to be harder, so it's going to, we'll see how it goes. Ready and go. This I actually think I got. So that is root 2 to the x squared minus that to the 6 is going to be 2 cubed is 8. Lots of root 2 to the x plus 12. So I'm going to call that y squared minus 8y plus 12 is 0. So y minus 2, y plus 6 is equal to 0. So root 2 to the x is equal to 2, or root 2 to the x is equal to 6. So x is equal to 2 on this one. And here, that is 2 to the half x equals 6. So a half x is equal to log 2 of 6. So x is equal to 2 log 2 of 6. And the sum of them is 2 plus 2 log 2 of 6. But that is 2 log 2 of 2 times 3, which is equal to 2 log 2 of 2 plus 2 log 2 of 3, which is obviously 2 plus 2 log 2 of 3. So adding them together, you get 4 plus 2 log 2 of 3, which is f. Ooh, glad I spotted that. And again, that was 39, right? Your damn question number, right? Split. That felt okay. Straight line passes through that. What is the perpendicular distance? That looks involved. Skip. Intersects the x-axis at the point. Okay, this... this looks like it's going to be okay. Because I look at that and I see, so 35 intersects the x-axis. Well, factorizing that out, that's x minus 3, x minus 2, so I'll sort that out later. Has a minimum at point C. So the minimum point there is going to be at a half, and then the y is going to be a quarter minus a half, which is minus a quarter minus 25 over 4. And that's C. Okay. Rectangle AB, so that's AB. DE has 2 of its vertices at AB. Yes, I know that. C lies on the edge of DE, so that is your triangle, DE. What is the area of ABCD? So that's 5 there, and that's 20. So it's 5. So it's 125 over 4. Don't make me work that out. 31.25, which is D. Rude. So 33. Sector of a circle has perimeter. So sector, draw a circle. Sector, so that's R, and that's theta and R theta. So 2R plus R theta is the perimeter of 24. For what value of the radius? Minimum possible area. So the area, so this is an optimization problem, is a half R squared theta. What I'm going to have to do is eliminate theta from here. So R theta is 24 minus 2R divided by R. So that's theta. Plug it in here. R squared into 24 minus 2R over R. Cancels, equals 12R minus, now don't mess this up. No, do this in stages. All right, it equals R into 12 minus R. So it's minus R squared plus 12R. Come on, Mira, you can do it. So we optimize by differentiating and setting to 0. Minus 2R plus 12 is 0. R is equal to 6, which is D. Okay. Okay, focus. I've got these wrong in the past, and I'm not going to get it wrong this time. So 31. This means that x to the 4 plus 4x squared minus 21 is less than 0. So that's minus 7 plus 3, x squared plus 7, x squared minus 3. So how would I sketch this? This has no solutions because I'm minus plus 7 minus 3. This absolutely works. There's nowhere where this is equal to 0. So x is equal to plus or minus root 3 here. If I sketch it, it's going to be some business that does something like this or whatever. But the point is, yeah, I think the answer is A. I think the answer is A because I don't think you get your root 7s because that's plus. So you can't have x squared equals minus 7. So I'm going to go for A. Hope I got that one right. Because I've messed those up before and I just... But that felt okay. I was double checking because it felt okay. Sum from y to infinity, this is going to be fine. So you can split them out. So it's going to be the sum. Let's write out the first three terms. So the first one from r equals 2. So the first, from that 1 over 2 bits, you're going to have a quarter, then an eighth, then a 16th up to infinity. The second one is going to be a ninth, a 27th, an 81st up to infinity. The third one is going to be a 16th, a 64th up to infinity. We're going to get the sums to infinity of all of those. So you're going to have a over 1 minus r, sums that one, and you're going to have a over 1 minus r for the second, and we're going to have a over 1 minus r, come on Miro, for the third. Here I'm going to multiply top and bottom by 4. Well, it's a quarter over a half, which is multiply top and bottom by 4. So 1 into 4 minus 2, so it's 1 over 2. Cool. Multiply top and bottom by 9. 1 over 9 minus 3 is 6. Multiply top and bottom by 16. 1 over 16 minus 4 is 12. So 6 on 12 and 2 on 12 is 9 on 12 is 3/4 is B. Okay, lap time. So here 27 equals that. Okay, simplify your surds first. So that's 2 plus 2 root 5. Oh, chef's kiss. Oh, wait, no. Oh, they're not to the same power. No. Oh, okay, so it's fine. It's fine. Everything's fine because I could still take a 2 squared out of that. So that's 4 into 1 plus root 5 squared all over 1 plus root 5 cubed. Obviously, that cancels down. So it's 4 over 1 plus root 5. Rationalize the denominator. 1 minus root 5. So you get 4 minus 4 root 5 all over 1 minus 5, which is minus 4. And that divides through and you get root 5 minus 1, which is A. Delightful. 4 mathematically similar solids. All right, let's see what happens. I'm in it now. So the ratio of the lengths of W to the lengths of X. So W to X, let's take the length area of volume. So W to X is 1 to 2, 1 to 4, 1 to 8. Got it. X, let's consider X and Y. They're saying the area ratio is 2 to 1. So that's root 2 to 1. So that's 2 root 2 to 1. And we got YZ. So Y to Z, the volume is in 1 to 2, so that's 1 to cube root of 2, so that's 1 to 2 to the 2/3. Cool. What is ordering cell increasing volume? Okay, so this is the, let's make, I don't like that. The Y's are lined up there, I suppose. So X to Y to Z in volume is 2 root 2 to 1 to 2. So 1 is the smallest. So it goes Y, then Z, then X in increasing volume. And I forgot there was a W. No. All right, let's see if that helps though. Not the first. Y, Z, X. Yeah, okay, so I actually do need to consider the W. Bollocks. So what I'm going to do, let's just consider, okay, so I'm going to have to multiply by root 2 to make that 4. So I'm going to have to multiply everything by 2 root 2 to make that equal to 8. So W, X, Y, Z, multiply by 2 root 2, and that's 1, and that's 8, and that's 2 root 2, and that's 4 root 2. So it's W, Y, Z, X, which is C. Probably a faster way of doing that. Sue me. Cool. So how much time have I got left? Vertices there. Arc of a semicircle. In terms of x for the area of this triangle. Well, the area of the triangle is half base times height. The base is 10 and the height is y. So the area of the triangle is 5y. So all we need to do is get y in terms of x. And that's done from the equation of the circle. So we know that x minus 5 squared and y squared, nope, yes, is equal to radius squared is 25. So we know that y squared is 25 minus x minus 5 squared, which is 25 minus x squared plus 10x minus 25 is 10x minus x squared. So y is root of 10x minus x squared, and area, which is 5y, is 5 times that, which is a. Cool. Oh, that's it. Oh, I've skipped it. Oh, no, that's not it. Okay, 21. 21. Find the value of that. Right, so that's the integral from 1 to 4. It's minus 3 over 2. So that's 2x to the half minus 3x to the minus 3 over 2 dx. Raise that to 3 over 2. Divide by that, you get 4/3 x to the 3 over 2. Raise that to minus a half. So divide by that 6, x to the minus a half. Put that in for 4 and 1. So that becomes 2, then 8. So that's 32 over 3 plus 6 over 2 is 3 minus, put the 1 in, 4/3 plus 6. So that minus that is 28 over 3 minus 3 minus 9, 19 over 3, which is a. Done. I've got 2 minutes left. Let me go back and second pass things. So I did that one. I didn't do that one. Okay, let's see what I can do. 37, straight line passes through the points x0, 2a, and a0. Perpendicular distance of the point a to a, which is there. From this line, that's that one. Let me draw the rectangle. This feels very similar triangle-y. So if that's a and that's 2a, this entire thing is root 5a. And these are going to be the same angles. So that's perpendicular, that's perpendicular. So that would be the hypotenuse. So let me similar triangles this. So 2a, a, root 5a. And then if I draw the similar one, where the hypotenuse this time is a, that's clearly shrink it by root 5. So that's 2 over root 5a, and that's a over root 5. And that's the hypotenuse, and I want the long side, so that's 2 over root 5a, which is c. Done, and I've got 30 seconds left. I did that one. Oh, I think I'm done. I'm not going to get anything checked in. All right, I'll stop there. All right. Again, didn't have things flagged, so it's not quite the same as you would get it. I think I'd be a bit more rigorous with like going back and checking things. Let me see how I did. I think a couple of these I actually am going to have to explain because I just rushed them. But I started here on 39. Let me first check. ENGAA, answer key. 39, is it F? Yep. 35, D? Yep. 33, D. 31, A. 29, B. 27, A. Let me zoom in a bit just in case you need it. 25, I said C. Let me get back in for that. What did I do? Oh man, I like this kind of stuff. So Wx is a 1 to 2 ratio, so the volume ratio is 1 to 8, certainly. Surface area is 2 to 1, so that's root 2 to 1 in the length and 2 root 2 in the volume, correct. Ratio of the volume of y to the volume of x. If that's 1 to 2, well, it's 1 to 2, the end. Increasing volume. So the y's were already lined up, so I could smash those together. And multiplying everything by 2 root 2 gave me that. So it's w y z x, which is b. So tell me why I wrote c. What is wrong with me? Everything's fine. Everything's fine. Not a problem. Not a problem. I am okay with the fact that my number one source of marks lost in this entire thing is getting the right answer and not submitting it. Everything's fine. We're fine. We're well adjusted. Everything's fine. God damn it. All right. So, given how fine everything is, let's move on to 23, which I didn't mark, but that's fine. So 23 was A, 21 was A, 37 was C. So I would have got full marks. That's fine. I'm at peace with this. Let me check the split times. So the first one I got done in 1:29, so perfectly on pace. I skipped in 11 seconds. This was 1:22. This was 1:17, 1:20, 1:44, so a little over, but perfectly fine. 57 seconds. We were deep enough that this 2:18 didn't matter too much. 1:15, 1:03. Went back for a 1:30. So yeah, that pacing was really good. It's just a shame I'm illiterate and can't find the actual correct answer among the solutions. So that's 2 out of 3 marks lost on that so far. But again, I'm over it. I'm over it and everything's fine. So reset, time for the physics. Which again, I'm going to go back to the NSAA for. Where's the physics? Hold on, I'm gonna. Excuse me. Physics is there at the top. Okay. Okay, so round 3 physics. Let's see if I'm going to be as illiterate this time. Again, I've got half an hour. Oh wait, no! What am I doing? I said I would go through some of the method because I had to skip steps for the interest of time. Let me go back and just check some of this stuff. So I'm going to go back to the bottom. So did I have to skip anything there? Yeah, let me just explain in a bit more detail in case you need me to. So on this one, I know stealth quadratic, you have to get them to the same base. It should be of the form of something to a power and something to that power times 2. So I knew it was going to be, I knew it would have to be root 2 to the 2x because I needed that 2x. Oh, let me write this a bit bigger. I needed that 2x to make it a stealth quadratic. And then I needed to make that root 2 to the 6 using my power law, splitting this out, times root. Let me just write this properly. So root 2 to the 6, root 2 to the x plus 12. So that is where I got my y squared from, using y is equal to root 2 to the x. And then this to the 6 is 2 cubed, which is 8. So that's where that came from. I think the rest of that was self-explanatory. Yeah, I was happy I spotted that because I looked at them and I was really worried I didn't get one of my results. But then I was seeing this log 3, which incentivized me to split this out into 2 times 3 and then simplify from there. So here I explained that. That was, I'll come back to that and explain how I knew those were similar triangles. So here, I think that was pretty self-explanatory. You all can factorize that quadratic. You don't need me for that. And then this I did from, I should really have done it from from completing the square, but I knew from symmetry that it was going to be halfway in between. Or rather, sorry, that's not what I did. What I did mentally was I did halfway complete the square. So I did in my head go, well, that's x minus a half squared. I just didn't, to be honest, I should have followed it through. That was just laziness on my part. That would have been faster, and I should have done that. Okay. So where else do I need to explain anything? So this optimization problem, this was fairly self-explanatory. You've seen these a lot in differentiation, where you form two equations, combine them. So I knew I wanted the area in terms of r. So I needed to eliminate theta. So I formed two equations. I made theta the subject, substituted in, differentiated, set to 0. That's pretty standard fare. This, again, I over-explained this one so as not to get it wrong. I didn't know for certain. No, I didn't. Yeah, I mean, I didn't know it would look exactly like that, but I knew it would have two roots. And so I drew a representative quartic graph that would have only two roots just so I could kind of place myself. I knew it was a positive x to the 4, so I drew it like a W. I knew it was going to be minus root 3 plus root 3. So I just went from there. Here, I think this was self-explained. I explained it as I went. Sum to infinity is a over 1 minus r. Always write out the first few terms of the series just to understand what's going on. Usually the best bet. It means that this r over 2 doesn't have to mess you up, because I didn't even think about it. Once I got my series, I just went crazy. Here, yeah, I explained the trick. Here, I can't even talk about it. But no, it was similar lengths, areas, and volumes, which was actually a Math 1 technique from GCSE. Here, yeah, the trick is really just spotting. And this is so often the case in coordinate geometry. People think that when this is a right angle triangle, which you know it is because that's in the semicircle, so you know that's a right angle, people think you want to calculate that length and multiply them together to find the area. Not so. Any two distances within the triangle that are perpendicular, you can use. So it's much more common in coordinate geometry to use x and y. So the total base in terms of x, total height in terms of y, which is how I was so quickly able to get the 5y out of that. From there, I think that was explanatory, but let me check. 23. Yeah, then it was just classic circle equation business and making y the subject. Cool, nothing issue there. And this, again, a lot of people want to do some fancy nonsense, but this is just classic polynomial integration, where you just use your power laws and just do it. I personally like doing this at the end, where I take the anything over 3 and combine those first, and take all the integers and combine those first. So I'm not having to like take all of that to 3, take all of that over 3, and then get some bigger numbers. It's just a way I save some seconds. So I think the math there was pretty okay. Right, time for the physics. I'm going to get my timer back out. I'm going to get myself some clean space. And we're going to start. Can't even be bothered to read that. Nope. Oh, I did these questions with someone earlier. No, not entirely. So I've done this one earlier today, actually, so that's unfair, but whatever, I'll take it. So 39. So they travel from a source. So it travels a distance x. So distance equals speed times time. Let me zoom in. This is not clear. Distance equals speed times time, which means that time of the p wave is equal to the distance x over the speed of p, which is 5 kilometers per second. The time for the s wave is the distance over the speed of the s wave. The p wave is going to get there first, so this time is going to be longer. So the difference in the time is 30. Make those over 15. So multiply this by 5. Multiply this by 3. 2x over 15 blah, 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 equals 30. Cancels the 2, cancels that to make that 15. And it becomes x is equal to 225, which is E. I'm going to lock that in. In fact, I didn't count the first skip. Whatever, my splits are going to be a little bit off. This is fine. So again, that was 39. Moving down. So this one, and again, this one I saw earlier, so a bit of spoilers on this one. So what happens is you draw your cylinder. The piston has gone down to here. And when it's in equilibrium, you have to remember this air pressure, which is 1 times 10 to the 5. Now, this weight is mass times g. The mass is, so it's 500 newtons acting down. The pressure is that 500 newtons acting over the area of 0.02. Let's multiply by 100 and then cancel that to make that 25. So that's 2.5 times 10 to the 4 is the pressure of the weight acting down. And then you've got the new pressure of the gas acting up, and these are in equilibrium. So what we know is that the new pressure of the gas is 1.25 times 10 to the 5. And we know that P1V1 equals P2V2. So 1 times 10 to the 5. Now, density is mass over volume. So volume is mass over density. Gas cannot escape, so the mass is the same. So V1 is the mass over the first density, which is 1.2, is equal to 1.25 times 10 to the, come on, Miro, times over the new P. M's cancel. Sorry, that's times 10 to the 5. The 10 to the 5's cancel. So multiplying this up, you get the second density is 1.2 times 1.25, which is 6 over 5 times 5 over 4, cancels, 3 over 2, 1.5, E, done. Okay. So here, again, I did this one before, but I wouldn't do this in the real thing. I did this one before. Okay, so apparently the mock is entirely taken from this paper. This is inconvenient for you, but sorry about it. No, I'm going to skip that. This one I do know, so I'm just going to go for it. So first of all, when the speed, I'll explain this later, when the speed flips, the voltage is going to flip. And we know the further we get out, if that goes to infinity, it's going to die away to 0. So the answer is just going to be D. So I'm going to lock that in. No working required. Okay. A piece of metal. Now we're into the new stuff. Cool. Piece of metal mass is in thermal equilibrium, hot liquid at that temperature. Metal is removed and immediately placed in 100 grams of that. Okay, so the energy lost by the metal is M C delta T. And that energy is equal to the energy gained of the water. So the equals M C delta T. I'm going to zoom out so I can actually see the equation I've written. So what that means is, so that is going to cancel down. That's just going to be a 2 over there. I can cancel a 0. So T minus 26 is 12 times 420 all over 35. I'm going to cancel 7. I'm going to cancel that. 12 is 144. So T is equal to 170 degrees C, which is D. Okay, split. 34. Whatever, 34. Single beta decay to form stable isotope Y. Only X and Y. So there's more Y. Yeah, that's increasing. present in the sample after a long time. The mass is a constant 50. What's the half-life of X? So you don't lose mass in beta. So there was mass of Y. So there was initially 30 grams of X. And then after one half-life, that should be 15 grams of X, along with the initial 20 of Y. So I'm looking for 35, which is 2 minutes, which is C. I'll explain later. Cool. So 33. Uh, 20 particles, electrons, 4 atoms. Which of these could be of a different isotope to Q, but the same element of Q? Okay. So X. So you added charge to that, so it could be X. X could be equal to Q minus. But that's an ion. That's not a different isotope. That's the same isotope, but as an ion. So it's not that. W, you can just give it a neutron. So that's possible. Y, you can make it lose an electron and gain a proton, so a neutron. So that's possible. And Z is gaining 2 neutrons. So yeah, X, Y, Z, which is H, is what I'm going for. Okay, split. Okay, this one I also went through this morning, but not from this paper. So they're clearly stealing from this paper a lot when they did the mock. Okay, so the point here is on 32, that's the speed. That's the twice the wavelength. So the wavelength is equal to 2. So V equals F lambda. So frequency is speed over lambda is 2 over, nope. It's 500. No, let me do this better. So speed is wavelength over time period. Time period is wavelength over speed. The wavelength, as we said, is 2. The speed is 500. Let's double them both up to make that 4 over 1,000 and get that the time period is 4 milliseconds. So what that means is in 4 milliseconds, it's done a full thing. So 7 milliseconds is one complete wave and 3/4 of the next wave. So it's going to go down, down, up, and it's going to be at exactly 0 from that point. So here, 31. Child is bouncing a ball of mass thingy vertically up and down on a bat. Hits the bat. The duration of contact is that. Hitting the ball, and immediately after it loses contact. Immediately before hitting the back to me. Okay, so the change in momentum immediately is the mass times the change in velocity. Cool. The average force is rate of change of that. So that over 0.2 is the same as multiplying by 5. No, I'm going to keep the 0.2 so I can cancel 108. I'm going to call that. Well, let's call that in fact, it's that 1.6 all over 2 is 0.8 is 0.64. No, 6.4. Sorry for the working guys. All right, that's D. I'll come back to that. So here, no, don't give me a graph. Don't want it. No, I'll do it. Okay. So 30 lamp and resistor are connected in parallel to a 6-volt. So they're in parallel to a 6-volt lamp, resistor, parallel. So they both have 6 volts on them. So that's Jesus. Oh, you would not get this in the real thing. In a second circuit. Okay, let's so 6 current in the lamp is recorded. So the lamp I know is going to be this guy. So that's going to be 0.35. So it's D, E, or F. In the second circuit, the lamp are now connected in series, and the current is that. So it's the same current in both. The potential difference across V is recorded across the lamp. So the lamp is this guy, 0.18, frac it up. It's about 1 point something. So I'll call it D. Okay. So here, more circuits. Love circuits. Let's keep it going. 29. 2 ammeters. So the current is going to split. So there's 1.8 going that way, which means there is 1.5 going the other way. Which means that the voltage on this branch is V equals, I'm not going to fall for it, V equals IR. So that's 1.5 times 3. So that's 4.5 volts on that branch, which means there's 4.5 volts on this branch, and R is equal to the 4.5 all over the 1.8. Let's multiply by 10 because decimals equals, nope, 9 it. 5 and 2, 2.5 is B. Okay. So here, power supply, electric motor at that, 60% is fit. How much is wasted? Well, 0.4 of that is wasted. So waste is 40% of that power. Half an hour is, 30 minutes times 60 seconds. How am I going to do this? So that's 1800. Make that 4. So 3200 times 1880. So it's going to have 3 zeros, and then it's going to have a 6. So I'm going to call that G. Okay. Okay, ultrasound. Let me zoom out. Find a crack inside a cuboid block of metal. Ultrasound probe is head in contact. Short pulse is sent to the metal block and reflects. So that's how long it takes to get back. And the returns of the reflections to the probe. Okay, what's the distance between the bottom surface and the crack? Okay, so I'm going to zoom in. So what we know is that so let's call that. So the strength. So it takes 2 milliseconds to go there and back, and the speed of ultrasound is 5,000. So distance equals speed times time. Well, first of all, let me mark the question. This is 27. So distance is speed times time, which is 5,000 times 0.2 milliseconds. So the thousands are going to cancel, and it's 5 times 0, so that's 2.5 meters. Except no, because that's double the distance. That's there and back. So it would take 1 millisecond just to go there. And I've done this completely wrong anyway. So it would have been time to go there is 0.1. So it's 0.5 meters deep. Because I did that wrong again. Okay, so there and back is 0.2 milliseconds. Just there is 0.1 millisecond. The milli contradicts that, so it's it's 0.5 meters deep in total. So the distance between the bottom surface and the crack. So if that is x, and that is 0.5, that is 0.5 minus x. And that distance, so twice that distance is 1 minus 2x is equal to 5,000 times 0.12 times 10 to the minus 3, where the thousands cross out, and that becomes 0.6. So 0.4 is 2x, and x is 0.2 meters, which is A. That took way too long. So 26. Block of mat is pushed along a rough horizontal surface by a constant force of 8 newtons. Accelerates uniformly from rest. from rest. Okay, let's see about it. So V equals U plus AT. So 2 is equal to 0 plus 4A. A is equal to 0.5. Then we're going to F equals MA it. So that's the frictional force. That's your 8 newtons. So 8 minus the frictional force is equal to MA is 3. So F is equal to 5. That's the frictional force. So how far does it travel? Distance is average speed, which is 1 times the time of 4. So it travels 4 meters. And so the work done is 20 joules because it's force times distance. 25. Small piece of debris of that strikes at a relative speed of that. Just rest. Relative space station. So again, this is force's rate of change of momentum. So the change of momentum is mass times 15,000 all over a time of 0.01. I'm going to multiply by 100 to make that 10. Add a 0 there. What did I do wrong? Mass times change in speed over the change in time. Grams! Ah! Okay. So that's 0.1 times 10 to the minus 3. So knock off 1, 2, 3. Bam, 150 E, done. Never safe from units. Okay. 2 identical resistors are connected in parallel to a 6-volt battery. 24. 2 identical resistors and a 6-volt battery. 2 resistors dissipate a total power. One of these resistors, so each one is half of that, BT dubs. One of the resistors is removed from the circuit and connected to 12. So that is 6 volts. That is 6 volts. But also that total power dissipated means that's the power there. And P equals IV. So the current is the power over the voltage, which is 6, which is 4 times 1.5. Cancels, 0.1. I'm getting this wrong. I'm going to come back to it. I'm just not finding the right path. 2 large copper tanks of water connected to a solid copper bar. Temperature of the water in tank 1 is T1, T2. Okay, the force statements, changes can be made to the system at all times. This is the cold one. Which 2 changes? An increased rate of conduction. So you increase the rate of conduction by increasing the temperature gradient. So if you increase T1, that decreases it, so no. If you increase T2, that does increase it, so 2 is correct. To increase the rate of conduction, yep. If you increase the length, you decrease the temperature gradient, so no. If you increase the diameter, you increase the area, that does increase the rate, so it's 2 and 4, which is E. Cool. Next. So 22. Rider on a roller coaster moves very quickly, hearing it towards a solid wall. While moving, the rider shouts. Here's an echo of the shout. The echo is quieter than the original shout. How does the amplitude and frequency of the echo compare to the amplitude and frequency of the original shout? So if it's quieter, the amplitude is lower. So it's ABC. And they're moving towards the wall, so they are hitting, the sound waves are hitting the wall with a greater frequency. and they're reflecting off with a greater frequency. So here's a higher frequency. So I think the answer is C. Okay. 21. I normally like circuits. I was ashamed about that early one. Nope, focus, fine. Okay, so constant current, charge of that and that. Okay, so I can get the current from that. So it's actually that the wire lies in a uniform magnetic field. Magnetic force, okay, this is F equals BIL. And current is charge over time. Magnitude of the force. B. Q. Not going to fall for the units. 1.5 times 60. Cancels, 0.1. Cancels, 3. Cancels, 0.06. 6 millinewtons. So that's A. And I think that's first pass done. Okay, let me go back to the start because I don't think I did everything. I think, yeah, I didn't do this one. So mass, solid cuboid has a mass and a density, which means we know the volume. They have different areas. The pressure on the surface due to the cuboid is that. Okay. So I'm going to have to draw this out so I can see it. So let's call it X, Y, Z. We know that mass is equal to density times volume. So volume is mass over density, which is 32 over centimeters. Let's keep it centimeters. So let's make that 32,000 over the density of 4, which is 8,000 centimeters cubed. Cool. Which is X times Y times Z is 8,000. Noted. So the pressure, okay, the mass is 32. So the weight is 320. And that over one of the areas is equal to 1.6. Newtons. Okay, so 320 over 1.6 cancels. It's 320 over 1.6. Let's multiply by 10 first to make that 16 with a 0. That cancels for 2 is 200. So one of the areas is 200. So that means the other side length is going to be 40. So one of the side lengths is 40. Okay, and if we do the same thing here, so we can do the weight of 320 over another area is equal to 0.8. So 320 over 0.8 is another area multiplied by 10, thingy 4. So the other side length is, so there's a 40, there's a 20. So the third of these faces, so is when it's sitting down on that face, so that's 800. And the so 30, the weight over the 800 is going to be cancels, 8, 4, 10, 0.4 newtons per centimeter. So that's A. Okay. How am I doing on time? I got 5 minutes. Cool. Calm down. You're going to get them done. So you did that one. Sweet. You did that one. Love it. You didn't do this one. So let's do it. Okay. So let's see if it's enough time for me to have forgotten how to do this. It's not. What's happening here is that the elastic potential energy is being converted into the gravitational potential energy. So a half K x squared equals mgh. Now, this is a before and after case. So that's what's happening with the 30-gram slider and what's happening with the 20-gram slider. The K is a constant, so x, I'm going to call that x2, mass 2, height 2. And I'm going to rewrite that for mass 1. Apologies, this isn't a true life solve anymore, but can't avoid it. m2 over m1 times h2 over h1. So the second compression is 15. The first compression is 5. The second mass is 20. The first mass is 30. The second height is what we're looking for. The initial height is 20. So that's 3 squared is 9, is 2/3 times h2 over 20. Cancels for 10, so that's 30. So 270 is the new height, which is F. Okay, got about 3 minutes left. This one I think I did, and the answer was D. Note that that was my answer if I didn't actually write it down. Did it? Did it? Did it? I think I did all of these now. No, I got one wrong. Oh, God damn it. Which one did I get wrong? This is where flagging would have been helpful. No. It wasn't 31, was it? Okay, I'm just going to have to check. Oh, God damn it. Where did I start? Okay, 39 is where I started. So 39, I definitely have an answer. 36, D, 35. Well, that's poor exam technique on my part if I can't find the one I got wrong. 34, 33, 32, I have an answer. 31, I have an answer. Oh, it was the circuit question. It was a circuit question. So I got 2 minutes to get it done. Okay, so let's go back and redo 24. I'm going to split how long it took me to find that. That was ridiculous. All right, so let's redo 24. Anticipated total power of that much. So let's think about it. When one of the resistors is removed, so let's compare these two circuits instead. So this has R over 2 equivalent with 6 volts, and this has 12 volts with the equivalent of R. So V equals IR. They have the same current. Because V over R is the same. The V doubles and R doubles. So they have the same current. Okay, I've got a minute. Oh crap, what was that current? P equals IV. P equals IV. I equals P over V. Voltage of 6. So and I have to multiply that by 6 minutes. Cancels. That should be about 9 or 90 or something like that. I'm going to go for G. Bam. Nailed it. And I'm going to call it there because I only have 20 seconds to spare. Woo! Okie dokie. That's in the paper done. Let's see what silliness I got up to. First, I'm going to mark it. Then I'm going to no, I'll explain as I go this time. That makes more sense. And no, I should have left more room before the physics so I would know when it actually started. 39. Did I actually do 40? If not, that's insanely stupid. No, I did do 40. Okay, we just didn't do it first. Got it. So 39, E, correct. The difficulty here. Actually, this wasn't difficult. I was thinking about the next one. So 39, you just kind of do it. 38, the difficulty is understanding that you have that gas pressure coming from above. And using your gas laws, P1V1 equals P2V2. And then linking the volumes through the density to get to the density. There was a faster way if you knew that from the kinetic theory that pressure is proportional to density. So if the pressure goes up by 5/4, then the density also goes up by 5/4. So you could have gone straight to 5/4 times the 1.2, would have saved you some seconds, but this was like the more robust way. Let me just check I got that right though before I start. Okay, so 38, yep, was E. I skipped then 36D. How did I do that? Right, now this is complicated, and I think this is a good skip for a lot of people because you either know this or you don't. You could get there from the GCSE from knowing that as you move the magnet away from the coil, that will cut the field lines. So the field lines will cut the coil, inducing a voltage, inducing a current. Current in the coil induces an electromagnet, and it's going to oppose the change that creates it. So here, if this was, let me make this, hold on a minute. So for instance, if this was a north pole and this was a south pole, if this is being moved away, it doesn't, this coil does not want it to move away. So it's going to try and attract it back with a south pole. If it's being pushed towards, it's going to try and repel it by turning into a north pole. And the way it does that is by reversing the current, by reversing the induced voltage. So from that, you can deduce it has to be one. Let me just clear this. So it has to be one where it flips round. So it can't be these guys. And then from this point, like I said, as you move further away, the effect becomes less because if you were to move it to like infinity and then bring it back, clearly at some point it would have no effect on the coil. So it has to decrease with distance. So that's why I said the answer has to be D. My students, we can discuss this further if you need to. All right, so 35. D, correct. Was that tricky? No, this was just doing it. MC delta T equals MC delta T. And just take a note of how I simplify my working. There's lots of this because I can't be bothered to work out these numbers. You use strategic cancellation, you're going to be fine. 35. Did I actually get 35T? Great, cool. 34C, great. How was that? Yeah, that was fine. I think I explained that. 33, I think I explained that as well. That was, ooh, got it wrong. 33 was G. Guess what I did, guys? I said that that was not going to be an isotope. And so I went looking for WYZ and did not land on G. No, so I know what I'd be working on if I were in your position is just like giving myself the time to act. It's fine. Everything's fine. Everything's fine. So 32, the answer is C. So yeah, the way this works, the time period is 4 milliseconds. So if you have 7 milliseconds, that's one complete wave. And then, it's going to go one, let me get where did I put the thing? So it's going to be one complete wave there and back again. And then it's going to go 3/4 of the next cycle. Sorry, that, and then that. So it's going to end up back at P. So the displacement is 0 at that time. So 31, wait, I did get that right. 32C, yep, 31. I said D. 31 was E. Oh yeah, my messing here was just like beyond atrocious. So let me try that again. So I know I got the theory right. So the change in momentum, let me just redo this. Mass times the change in momentum is 8 all over 0.2. Oh no, I thought Is bouncing a ball vertically up and down on a bat. Each time the ball hits the bat, that's that. The speed of the And immediately after it loses contact is that. No, the change momentum mv rate of change of momentum over 0.2. How is it not 6.4? Am I missing something? I might need to find the working on that. Hold on, I'm going to go over here. I'm going to try and find that. I'm going to try and find work solution to see what I'm doing wrong. Which clearly, and this is clearly this I would categorize as conceptual because I can't see what I'm doing wrong. Hold on a minute. I'm NSAA 2022 work solutions. So what are they saying for question 31? No, they're saying 31 is D. Am I just looking at the wrong thing? Is that what? Oh, they say the same thing I do. They say the official answer is E. I believe this is wrong. Ooh. Ooh. I mean, I'll take the credit. I do believe I'm right on that, so I'm not going to claim that as a mistake. I'm sure that's correct. But showing you how my cancellation. Let's first multiply everything. In fact, let's multiply by 100, which would make that easier. 20. So cancels to make that 4 and 5. It's not the way I should have done that. But it's basically, it turns into 0.8 times 8, which is 6.4. Like, I'm sure that's the answer. So moving right along, 30 D, correct. I think I explained this okay. Potential difference. So here, yeah, in parallel 6 volts. So 6 volts. I know that they doesn't mark which one's which, but you know that the linear one is the resistor because that's ohmic. It's directly proportional. So we know that's the resistor. We know the curved one is the lamp. So at 6 volts, you get 0.3 amps. And when they are in series, the current is 0.18. So you look where that is there, and you get something less than 2. So I went with D. 29. 29B, correct. Did I explain that well? So that current means you get that voltage. And because these are in parallel, it means you get that voltage, which means you get that resistance. Nothing too complicated there. I think this was explained well. Let's see if I got this one right, because I didn't actually calculate it. So 28 was G. Yes. You'll notice I didn't calculate it the whole way through, because who could be bothered? I knew the zeros. I knew the next non-zero digit would be 6, and the only answer it could be was G. So I went with it, and it worked. This I messed up initially. 27A. Yep, got that right. I think I explained that okay. Yeah, let's go with it. Don't have a huge amount of time. All right, so 26 B. Yep, nailed that. That was pretty self-explanatory. The only thing I might need to explain a bit more is where the 4 came from. So distance is average speed times time. So it is 2 plus 0 over 2 times 4. So that gives you the 1 over 4 is 4. And then work done is force times distance, which gives you 20, which is B. 25. I got E. Yes. Units. Oh, units. Never ever say from units. Otherwise, easy. 24. Yeah, got that wrong the first time. I was really lucky that I spotted that trick by drawing the 2 diagrams side by side. That's going to be R over 2. So they were going to have the same current. V equals IR. I equals V over R. Both double. Yeah, the currents are going to be the same. So by working out the power here from 6 volts and that many watts of power, I could get the current multiplied by time to get charge. The 6 is canceled. It was much easier the second time round. 20, and I got G for 24, which I need to actually check was correct. Yes, it was. Okay, so moving back to 23. I didn't do any work and I think that was well explained. And I got E. Yep. 22. I got C. Yeah, but I might need to explain a bit more. So the amplitude being lower is pretty self-explanatory. The frequency is good if you know the Doppler effect. But basically, because I'm moving towards the wall, the wave fronts are being pushed together. And so the waves are hitting the wall with increased frequency. So they're being reflected back at me with increased frequency. If you don't understand that, we can go through that in session and maybe I can explain it a bit better for you. But 22 was C. 21 was A. F equals BIL. This is in the specification. Make sure you go through the specification line by line, because F equals BIL is not one that typically you've been taught in class yet, but it is an application of everything you understand from GCSE physics. Using the motor effect to increase the force on a wire, you increase the current, you increase B, and you increase the number of turns. And so that's what this is. It's magnetic field times current times the length. And I is equal to charge passing through in a certain time. So I put it through and did my strategic cancellations and got A. So then carrying on for the second pass, I went to 40. And I got an answer of A, which was correct. I think this was well explained, so I won't go further. 37, again, apologies. So I had a student this morning go through the multiple choice UAT mock, and it seems like they took a lot of questions from this exact paper. I did this paper blind, so I didn't check beforehand. So apologies for having, this wasn't me finding the solution, but this is really important. If you ever have a before and after case like that, especially where it's complicated, it would have been really complicated to go through, work out what K was, and then substitute that back in. So instead, I like to use this before and after method because that's going to cancel out a lot of the constants. So write out the second case, write out the first case, divide them through, see what cancels, and then by substituting, it makes your life a lot easier. And that, I believe, is everything I did. Let's go through some of my splits. So I forgot to include the first split for how long it took me to skip, but I can live with that. So I started on 39 and including the splits. Yeah, that was done in 122, so that was good time. Even explaining this to you, even with me knowing what the answer was to this question, I still did it in 2 minutes 1, which is still 30 seconds over. So definitely one to skip. Even if you understand it and it's going to take you too much time, just leave it. Build up your time bank. Come back when you're fresher and you don't have that time pressure on you. So 36D. Yeah, I knew this one. I got it in 18 seconds. 35, I got it in 25. I don't think I got that in 23 seconds. So I think I'm miscounting the splits. Let me try this again. So it was 122. Then it was 201. I'm missing something. I don't think this was done in 23 seconds. All right, you can if I'm doing something really wrong, I suppose you can check it, like you can check the time bar to see what I'm sort of doing. I have a feeling this was done in 140. So I'm just going to go as if that's the case. Then if that's the case, this was done in 50 seconds, which tracks. This was done in 119. This was done in 120. This was done in 103. 121. 48, 52, 228. Yes, I got stuck on this. So I think I am right with my splits. I got stuck on this. It was 228. Maybe should have been a second pass based on that timing. 112. So which is good. Oh no, there was. No, I'm getting lost now. This would have been the 112. Apologies. This would have been the 112. 115. 114 the first time. 49 seconds. 52 seconds. 59 seconds. And then I went back and spent 4 minutes. Yeah, then I went on that circuit question I didn't like, 24. So I would say most of those were good. There were just a couple that were a little bit over it. And so you can see, I think the passes are working well because the ones I'm doing in the first pass, I'm getting largely correct. And I'm getting them done in time. So hopefully you've gained some sort of tips and tricks there. I'm going to stop sharing screen because I think I'm done with that now. So I'll do a little bit of reflection now. So I think the main thing there is I'm illiterate. So I lost 4 marks, and 3 of them were for getting the right answer and just selecting the wrong answer. So that's good in that it shows that I have good conceptual awareness and that I'm able to execute my skills well. It's just me focusing on my exam technique. So in terms of getting every mark I deserve, that's what I should be focusing on. The only execution error I can remember is the minus a squared curve. So moving forward, that would tell me my pacing is good, even when I think it's not. I'm skipping the right questions. So there's a lot of stuff that's going right. And for me to get to the next level, I would just need to come up with systems to really check that I was marking the correct answer once I've got it. I also think for my personal practice, it'd be good for me to come up with systems to make sure I've noted which questions I'm skipping that I need to come back to. And there were a couple of moments where I lost track of what my exact split times were. But hopefully this demonstrates how you can use the system to get the maximum amount of marks. And if you do get to the end and don't have the time, look at the way I guessed in that math 1 based on how I did the working wrong. I knew it was wrong, but I had to make a strategic guess. And I did based on my working and I still got it right. So there are ways you can, even without the time to work it out fully, make an educated guess that maximizes your probability that you're going to get it right. So I'm going to leave it there. That's probably a long stream. Yep, I'm out at the 2-hour mark. So hopefully that's given you a good amount of stuff that you can use in your own practice moving forward. Guys, let me know any sort of feedback about how we can make this more useful for you. Really happy to take on board any suggestions. Like I say, this is kind of beta test. This is very in development. Let me know if you guys would prefer me to do different timings so you can actually be live if you think that would be helpful. I think for this, where I'm so locked in, it's kind of okay that you guys aren't here and I can send it to you afterwards. But if I'm doing more of like an explanation of a different topic, maybe it's better for you guys to be in. You guys let me know. So, all right, I'm going to leave it there. Work hard. Have fun. See you guys next time.